Section 2.7, Video 2, Verifying Logic Arguments. In this video, we will continue to cover the objective using truth tables to determine the validity of arguments. Let's start with example 3. We are given the argument, if Adam learns to drive, then he will not have an accident. Adam learns to drive or play video games. Therefore, Adam plays video games and does not have an accident. And we want to determine whether this argument is valid or invalid. For method 1, recall that we're using if we are given premise 1 and premise 2. Then, does our conclusion make the argument valid? So here we have our given information from premise 1 and premise 2, and we could rewrite those in symbolic notation. Premise 1 is a conditional if Adam learns to drive, and statement P, Adam learns to drive, would be the antecedent. Then the consequent is written as he will not have an accident, which is statement Q. The second premise statement is a disjunction. Adam learns to drive, which is statement P. The disjunction is or. Adam plays video games, which is statement R. Therefore, we want to determine if the conclusion, Adam plays video games, which is statement R, and, which is our conjunction, Adam does not have an accident, statement Q, will make our argument valid or invalid. So to begin, we need to convert our argument into a large conditional. If premise 1 and premise 2 are given, then we want to determine if the conclusion makes the argument valid or invalid. So here's premise 1 and premise 2. Then, that's our implication. We want to determine if the conclusion makes the argument valid or invalid. Let's begin working on our truth table. In our truth table, I'm going to start with our innermost parentheses, which is that conditional P implies Q. And that's our premise 1. Notice that now that we have 3 statements, statement P, Q, and R, we now need 8 cases to create our truth table. And these are given like we've used in previous sections of the unit. Right now, we're just using the P column and the Q column. And the P column is the antecedent and the Q column is the consequent. So the direction of the arrow is important. If you want to look through, we can determine the ones that give us a false truth value where we have a true antecedent and a false conclusion. And that happens in case 3 and case 4, and the rest of the cases would end up with a true truth value. The second part that we can work on in our truth table is premise 2, P or R. So we can work on the disjunction. With an or disjunction, we need at least one of the statements true. So we're going to work with statement P and statement R and connect them with an or. So we're looking for at least one of those statements true. Case 1 would be true. Case 2 has at least one true. So does case 3. And so does case 4. Case 5 has at least one true. Case 6 ends up with both statements false, so that gives us a false truth value. Statement 7 has at least one true, and case 8 has both of them false, and we end up with a false truth value. So now we have our parentheses on the left and parentheses on the right for the antecedent. We want to connect them with an and, which is a conjunction. So let's take premise statement 1 and premise statement 2 together. Premise statement 1 was if P then Q. Premise statement 2 was P or R. And so we're going to connect these two columns, with an and. Remember, for a conjunction and to be true, we need both statements true. That happens in case 1 and case 2, not case 3 or case 4. We again end up with both true in case 5, not in case 6. In row 7, we end up with both of them true, but not in case 8. Now we're going to go ahead and write the conclusion, R and Q. That comes here from the conclusion of our whole argument. So let's take a look at R and Q. Here's statement Q and here's statement R, and we're going to connect to them with a conjunction and. So again, we need both of them true. That happens in case 1, not in case 2 or 3 or 4. We end up with both Q and R true in case 5, but not in case 6 or 7 or 8. And then we can move on to the whole argument. And our whole argument is basically everything that's written here. We have our antecedent, premise 1 and premise 2 together. And we're trying to see if that implies, I'm going to expand my screen here, the conclusion R and Q. What we're looking for within our truth table is here's our antecedent, here's our if, and we're trying to see if that implies the conclusion. The direction of the arrow is important. Okay. The one that gives us a false result is when we have a true antecedent and a false consequent. And I see that in both row 2 and row 7. The rest of the cases would give us a true truth value. We have found the truth value of the whole argument, and not all of the truth values are true. It ends up giving us a false truth value in case 2 and case 7. And that tells us that the argument is not valid, it's invalid. And why is it invalid? It's invalid because when we found the truth value of the entire argument, not all the cases ended up with a true truth value. Let's use method 2 with this same argument. In method 2, recall that we're using the idea that in all cases other than a true antecedent and a false consequent, we end up with a true truth value. So if we have true implies true, that gives us a true truth value. Also, false implies true gives us a true truth value, and false implies false gives us a true truth value. So the only one that we're concerned about is when we have a true antecedent and a false conclusion. If we start out with a false antecedent, we end up with a true truth value. So we're not concerned about those. We want to show that if we have a true antecedent, our conclusion is also true in order to make our argument valid. So let's start out with premise 1. And with premise 1, we said was, if Adam learns to drive, then he will not have an accident. Premise 2 was Adam learns to drive, or the disjunction, Adam plays video games. At the conclusion was Adam plays video games and does not have an accident. So we're going to look at premise 1, then we're going to look at premise 2, and then we're going to look at the conclusion. Premise 1 is if P, then Q. Premise 2 is statement P or R. And the conclusion is statement R and Q. And we need to complete that for all 8 cases. Premise 1, we're looking at the statement P implies Q. And if you want to scan through, the ones that give us a false truth value is when we have a true antecedent and a false conclusion. And all the rest end up with a true truth value. With premise 2, we're connecting statement P with statement R using a disjunction. Here's statement P and statement R. And here we need at least one of those true. That happens in case 1, 2, 3, and 4. Here in case 5, we have at least one true. In case 6, we do not. We get a false truth value. Case 7, we have at least one true. And case 8, we do not have at least one true. Now we're on to the conclusion column. And the conclusion is statement R and statement Q. So we're connecting these two statements with a conjunction and. For an and, we need them both to be true for a true truth value. And the rest of them in this case would be false. Let's go back and take a look at where do we have our premise statements true. So remember that we're trying to show the premise statements that are true also give us a true conclusion. In the first case, we have both premise statements true and also a true conclusion. In the second case, we have both premise statements true, but notice that our conclusion is false. So this one is making our argument invalid. Let's keep going. Here we have our premise statements true and also our conclusion true. And also in case 7, we have our premise statements true, but notice that our conclusion is false. And that's another one that makes our argument fail to be valid. Notice that in case 2 and case 7, our argument failed to be valid, failed to be true. So is the argument valid? No, it's invalid. And our reason, how do we know? When we found the truth values for the premise statements and conclusion, our conclusion where the premise statements were true, our conclusions were not always true. And that caused our argument to be invalid. One quick note is that here in case 2 and case 7 is where our argument failed to be valid. And it was those same two cases, case 2 and case 7, where it failed in argument 1. It doesn't matter if you use, in method 1. It doesn't matter if you use method 1 or method 2. You'll end up with the same answer on whether your argument is valid or invalid. And that ends example 3.